Hail is one of the most fascinating and at the same time dangerous weather phenomena, capable of appearing suddenly and turning a warm summer day into an icy show of nature. At first glance, hail may seem like simply frozen rain, but in reality, the process of its formation is much more complex and intriguing. It all begins with massive cumulonimbus clouds that rise tens of kilometers high and contain enormous amounts of moisture. Inside these clouds, constant motion occurs. Warm air currents rise upward while cold air sinks, creating a closed cycle of circulation. Within these powerful air streams, tiny ice crystals form, becoming the first seeds of future hailstones. When water droplets collide with these crystals, they instantly freeze, forming a thin layer of ice around each nucleus. Strong updrafts then lift these particles back upward, where they gather more moisture and freeze again, growing heavier each time. This process repeats many times until the hailstone becomes too heavy to be supported by the rising air currents. Eventually, gravity wins, and the icy spheres rush downward, falling to the ground at great speed. The size of hailstones depends on the strength of the updrafts and the amount of moisture within the cloud. The stronger the storm, the larger the hail. Small hailstones the size of peas are quite common and usually cause little to no damage. But sometimes nature shows its power, producing icy balls the size of golf balls or even chicken eggs. The largest hailstones ever recorded exceeded the size of a baseball and weighed several hundred grams. Such icy formations can break roofs, snap tree branches, and leave dents on metal surfaces. Hail most often forms during warm seasons when the air near the ground is hot, but the upper atmosphere remains cold. This temperature contrast creates strong convective currents that lift moist air high into the sky. In some regions of the planet, hail is a rare guest, while in others it appears almost every season, becoming part of the local climate. Mountainous regions are especially prone to hail because of frequent updrafts and air turbulence. Hail is accompanied by a distinctive sound. The tapping on roofs, cars, and the ground resembles the beat of a drum. Depending on the size of the ice particles, this sound can be soft and subtle or loud and almost frightening. When hail falls, the air temperature at the surface usually drops sharply, sometimes by several degrees within minutes. This happens because the falling ice brings cold air from the upper layers of the atmosphere. After such a storm, you can often see mist rising from the ground, a result of quick cooling and evaporation of moisture. Despite its apparent simplicity, hail remained a mystery for scientists for a long time, since observing its formation directly is nearly impossible. Modern meteorologists use radars and satellites to track the development of cumulonimbus clouds and predict hail probability. However, the exact location and timing of hailfall are still difficult to forecast. Scientists even conduct experiments to prevent hail by using special aircraft that disperse reagents into storm clouds. These substances trigger the formation of many small ice crystals, preventing large hailstones from developing. This method, known as cloud seeding, is used in some countries to protect agriculture. After all, hail can destroy entire crops in just a few minutes, leaving fields stripped of vegetation. Vineyards, orchards, and vegetable farms are considered the most vulnerable to hailstorms. Therefore, in regions where hail is frequent, farmers stretch protective nets over their crops. These structures can soften the impact of the falling ice and save much of the harvest. Some companies even create sound-based systems designed to disrupt clouds, though their effectiveness remains debated. Hail also attracts the attention of atmospheric physicists, as it provides insight into processes occurring within clouds. By studying the structure of hailstones, scientists can determine how many freezing and lifting cycles they underwent. Under a microscope, hail reveals multiple layers of ice, alternating like rings in a tree trunk. These layers tell the story of its growth, a kind of diary of its journey inside a thunderstorm. Sometimes a tiny dust particle or grain of sand can be found at the center of a hailstone. This proves that even the smallest particles in the atmosphere can become the nucleus for ice formation. Interestingly, hailstones are not always perfectly round. They can be oval or have strange, jagged shapes. It all depends on the conditions under which they formed and the strength of the updrafts. Scientists note that hail often accompanies thunderstorms, but can also occur without lightning if the atmosphere is unstable enough. When hail reaches the ground, it quickly melts, leaving behind wet streaks and small streams of water. After heavy hailstorms, piles of ice can remain, looking like the aftermath of a winter snowfall. In some cities, cleanup crews even have to remove the ice as if it were snow from a blizzard. Despite its suddenness, hail is an important part of Earth's water cycle. It returns moisture to the ground, replenishes soil reserves, and influences local weather patterns. For many people, hail is a mesmerizing sight, especially when viewed from a safe place. The bouncing ice pellets reflect light and create a captivating play of colors and reflections. Children often try to collect hailstones, amazed that ice can fall from the sky in the middle of summer. From a physics perspective, hail is an excellent example of the interaction between heat, cold, and gravity. It demonstrates how dynamic our atmosphere is and how rapidly energy processes occur within it. Hail also helps scientists better understand thunderstorm structures and improve storm predictions. Each hail event results from a delicate balance between uplift, cooling, and particle mass. There have been remarkable records in the history of hail regarding its size and weight. Some hailstones have reached the diameter of a grapefruit and weighed as much as a small apple. The falling speed of such large hailstones is also impressive. They can reach dozens of meters per second. That's why large hail can leave noticeable marks even on hard surfaces. However, in most cases, nature limits the size of hail to moderate levels that cause minimal harm. In different regions, folk signs connect hail with changes in weather. Some believe that heat follows a hailstorm, while others expect heavy rain afterward. There's some truth to these beliefs, since hail clouds often form during atmospheric front shifts. Once the front passes, the air becomes clearer, the sky brighter, and the smell after the storm incredibly fresh. Humans have observed hail for centuries, trying to understand its nature and predict its appearance. Today, this phenomenon is studied using modern technologies and meteorological models. Scientists create computer simulations to reproduce the process of ice formation in the atmosphere. These studies help us better understand climate change and extreme weather patterns. In the future, hail predictions may become more accurate thanks to artificial intelligence and satellite data. The more data we collect, the higher the chance to prevent damage to agriculture and infrastructure. Hail reminds us how powerful and unpredictable nature's forces truly are. Even a small piece of ice falling from the sky tells a story about incredible processes happening kilometers above us. In this sense, hail is like a messenger from the heavens, carrying the history of air, moisture, and temperature movement. Each hailstone is a frozen dance of wind, water, and cold, a snapshot of the atmosphere in motion. When we see hail, we should remember that it's not just ice, but the result of nature's delicate and precise balance. It reminds us that everything in our atmosphere is interconnected, from a tiny dust particle to vast storm clouds. Perhaps that's why watching hail is so fascinating. It combines beauty, power, and mystery all at once. Every hailstorm is like a short performance where ice, wind, and light play the leading roles. And when the last piece of hail melts in your hand, it feels as if nature leaves behind a silent message about its might. Hail is not just precipitation, it is a reminder of our planet's living breath, constantly moving, changing, and astonishing us. The footage shown in this video is intended to create a general atmosphere of events. Some clips are shot on real locations, while others are used symbolically for visual context. This channel is not an official news source. The footage is compiled from footage from the last 10 years.